Okay, so today we're finishing up our study of the conic sections, and this is the last one. It's called a parabola. And by definition, a parabola is the set of all points in a plane that are equidistant from a fixed line called the directrix and a fixed point called the focus. So here would be this thing called the directrix, this line called the directrix. Here would be the focus. So if I take any point, this distance here from this focus to this point is always going to be the same as the distance from this point to this line. That's how the parabola is going to be made. How it's actually formed from that double cone that I keep referring to is right here. If we have that double cone and we cut it with a plane going at an angle so that it does not intersect the top part but does intersect the bottom, or just the top and not the bottom, then we get this parabola. Okay, so we have all those different ways of cutting that cone, and that's where the conic sections come from. When we did parabolas early in the year, we always had them written like this: y equals 1 over 4px squared. This would always be one that opens either up when this 4p was positive or down when that 4p was negative. When we had x equals 1 over 4py squared, that was 1. As if p was positive, it would open to the right. Okay? And in this case, actually, the origin would be our vertex, so consider that slid down to there. But we're going to be having some transformation, so that's why I have them not exactly with the vertex at the origin. Now, the way that conic sections are written a lot of times, though, is in this form called standard graphing form. In standard graphing form, a lot of times they put the squared on the left side instead of the right. But it's the same rule. If we have x getting squared, just like if we had x getting squared earlier in the year, it opens either up or down. And this is just saying if p is positive, it's up. P is negative, it's down. HK is going to be the vertex. If it opens right or left, then y is going to be getting squared, not the x, just the y. When p is greater than 0, positive, it opens right. P is negative, left. So this is going to be very familiar to you. The directrix is always going to be p units away from the vertex, and it's always going to be outside of the parabola. That focus is that point that's p units away from the vertex, and it's inside the parabola. We're also going to be talking about endpoints of the focal chord. This is a distance of 2p away from the focus. That focal chord, that 2p, that tells us how wide that parabola is. Let's look at an example. All right, so looking at this first one, what's our vertex going to be? 0, 0. So we'll go ahead and plot that. X is getting squared, so we know it has to open either up or down. Which way? Up. So I might want to jot that down. It's up. Okay, now I'm going to find my p value. So I say 4p is equal to 8. Okay, this bottom value, that's always going to be 4p. So p is going to be 2. So I know then that my focus is going to have to be 2 units up since it opens up. I also know that the length through the focus is going to have to be twice this much. So it'd have to be 4 all the way through the focus. So if I go over here 2 and I go over here 2, that's going to help me to create a nice graph of that parabola. So that's the way it's going to look. So that focus right there, that focus is going to be at 0, 2. The endpoints of that focal chord are going to be at negative 2, 2 and positive 2, 2. The directrix has to be p units outside of the parabola. So it's going to be down here. So what's the equation of that directrix? Right. And then the axis of symmetry is just going to come down through here, and that's x equals 0. All right. Let's do this one. Okay, so what's the difference here? Well, now y is getting squared, and this is a negative. So which way is it going to open? Up, down, right, or left? Left. So we still have our vertex at 0, 0. Our focus, we know this goes to the left. So the focus is going to have to be p units left because it has to be inside the parabola. So where's the focus going to be then? What's p first of all?
1. Negative 1.
Yeah, it's actually going to be -1. So I'm going to go 1 unit here to the left. So that focus is at -1, 0. What is the length going to be through the focal chord? The length of the focal chord? 2. I go 1 up and 1 down. And so I'll just call those FCE for focal chord endpoints. That's going to be at -1, 1 and -1, -1. And then the directrix has to be 1 unit outside of it, so right there. So the directrix is going to be x equals 1. And finally, the axis of symmetry is going to go right through the focus as well as the vertex. So what's the equation of that line? Yep. All right, let's do some more difficult ones. Okay, so on this one, what are we going to have to do to get it into the form that we need it? Complete the square, right? So I'm going to have x squared minus 6x equals 4y minus 29. So we're going to take half of this and square it. What do we get? Add 9 to both sides. So that's going to give me another name for this is x minus 3 squared. This is going to be 4y minus 20. Okay, so now I'm going to have x minus 3 squared, and this is going to be 4 times y minus 5. Based on that form I have to have, I want to have my squared term over here, and so this needs to be a 1. So I'm going to divide both sides by 4. And so now I have it in the correct form. Okay, so this is a little tougher. Let's go through it. What's the vertex going to be? 3, 5. Okay, so I want to be able to get that in there. I'm going to move my axes down and over a little. So there's going to be my vertex. X is getting squared and P is positive, so which way is it going to open? Up. Okay, so let's go ahead and find our focus. What's P going to be, everybody? 1, so I'm going to go up 1 for the focus. I'm going to have to go out 1 unit in each direction for the focal chord endpoints. So that's going to be at 2, the focus is going to be at 3, 6, first of all. The focal chord endpoints are going to be at 2, 6 and 4, 6. And we'll just find the directrix. Where's the directrix going to be?
Equals 5.
Here's,
Y equals 5.
nope. Y equals 4. Right here's going to be the directrix. Has to be p units outside. Okay? All right. Let's go ahead and complete the square on this one. So I'm going to start it. I'm going to have y squared plus 2y equals negative 10x plus 9. I'm going to take half of this and square it. That's 1. Add 1 here. So this is y plus 1 squared equals negative 10. I'm going to factor that out. If I take a negative 10 out of here, I just get x. 10 divided by negative 10 is going to be minus 1. You guys see that? Make sure you factor the negative out of there, so that becomes a negative 1. So what's going to be our vertex this time? 1, negative 1, good. Okay, now I need to get it into that form, so I'm going to have to divide by negative 10. Okay, and so then right here is going to be 4p. So 4p is going to be negative 10, so p is going to be negative 2.5. Right, so that means that to find my focus, which way am I going to go on my focus? Up, down, right, or left? Left, because this is going to open to the left with y getting squared. So over 2.5 this way. So that's going to put me at negative 1.5, comma, negative 1. I had to go to the left 2.5 units. Now, I have to double this, and that'll be the total length of my focal chord. But I would have to go up 2.5 and down 2.5. So there's the way the parabola is going to look. So those focal chord endpoints, my x did not change. But I went up 2.5, which put me at 1.5. My x did not change, and I went down 2.5. So there would be my focal chord endpoints. And then finally the directrix. I don't care if you find the axis of symmetry. I have to go backwards 2.5, so go to the right 2.5. Where's that going to put us? 3.5? Is that x equals or y equals? X equals 3.5. Okay? All right, going backwards now. Write the equation of a parabola if the vertex is -4, 2, and the directrix is x equals -6. A lot of us are visual. I think it might be helpful to go ahead and draw just a little sketch of this. -4, 2 is our vertex. X equals -6 is our directrix. I know the vertex, I know the directrix. Okay, so first thing I'm going to think about is which way is this opening, up, down, right, or left? It can never touch the directrix, so which way is it got to go? Right. So if it goes to the right, what is it that gets squared, x or y? And here's the way I think of it. See how I have two y's? So I think y is getting squared. That helps me. In this case, see how I have two x's? So x is getting squared. I don't know. That's just the way I think of it. And so therefore, this is going to be y minus 2 squared equals x plus 4. That much I know. The other thing I need to know is 1 over 4p. How can I find p? Not quite. I know p is 2. Okay, so this is going to have to be 1 over 4p, so just 1 over 8, right? Would it be a positive 1/8? Yeah, because it's going to the right. So we can write it like this. Okay. All right, last one. Same vertex. Oh, thank you. That changes things. Here's our focus. Our directrix at y equals -6. Okay, so what are we going to have to find if we've got the focus and the directrix? We have to find the vertex. So the vertex has to be in the middle of those two. So how far is it from 2 to -6? 8. So where's it going to be? At -2. At -4, -2. Right there is going to be the vertex. Which way is it going to open? Up. What's going to get squared then? X. So I already know this vertex. I like to write the vertex because sometimes it's tempting to use that focus, which I just kind of read it wrong even, but there's that vertex. That's what I'm going to use when I go to write this. So it's going to have to be, what's getting squared is the x, so it's going to have to be x plus 4 squared equals y plus 2. And then this has to be 1 over 4p. And what is p? It's this distance or this distance, 4. So it's going to be what here? 1 over 16. And there we go. Okay? Not too difficult, right? Because we've done it before a little bit, just not this as in depth.